Yeah, so that's super cool. So yeah, so what we can do, if we do go through and you see us making a typo, you can see there's still poll results coming through there, which is cool. People still going through the poll. Fantastic.
While
Thank you for that.
I would say, like, if you like this channel, subscribe to this channel. If you want to sign up for email to, get the resources, we send out reminders and links before the show, like every week. So you can register at the landing page. Like I said, like last week, there is a catch. For some reason that you will only receive the email if you put your language as English at the moment, and we are still working on that. So if you want to get some reminders, the link for every week, please subscribe and also register at the landing page.
Fantastic. All right. Thanks for that. Thanks for that, May. So let's flip back across now to the main thing here. So what we wanted to do is also we wanted to call out those who completed the homework last week. So if you jumped on LinkedIn, we asked you a question, we threw out the gauntlet and asked you to pop in a CDK construct from last week's episode, or at least your favorite service. We wanted to kind of pop that in there. So if we go ahead and just bring over some of the homework there from last week. Thank you so much for everybody who completed this homework. So first of all, Alex, nice work. So you've gone through and, the classic, AWS, Amazon S3 bucket, right? So we've gone through a nice little construct there, and we've added KMS, so the key management service, right?
KMS, yeah.
Yeah, that's awesome.
That's cool. And version true, that's great. So having the version enabled on the S3 buckets, actually, that's a very useful feature.
Absolutely. And Shamaz, thanks for popping through. So going through and providing app sync, so your Graph API or GraphQL API. So again, great example, super cool service. Definitely great. You pop that in there.
It's great for mobile and web applications, and love building through app syncs, and it's super cool service. And Brian from Canada's using Java. When I see that, Ben was like, May, do you want to talk about it? Because I used to code with Java.
Yeah.
But, very cool. I haven't tried Java, to be honest, with the CDK. Mostly it's on like TypeScript and JavaScript. So it's very cool to see using the Java on the CDK. And I was planning to try other, because you can try the JVM hosted language like Kotlin and Groovy, and love Kotlin. So I would love to try that Kotlin with the CDK. So that is really cool to see that.
Absolutely. And finally, Casino, thanks for popping these through. So, coming in, so we've got our HTTP API there. Really great call out. And that's quite a new feature for Amazon API Gateway, which we're going to talk about a little bit more actually in the next episode, where we go through Amazon API Gateway in a lot more detail. But great call out, and it's a great new capability for API Gateway from a performance perspective, and really getting that, bringing the latency and just getting that extreme scale and performance. So awesome call out there. So thank you for doing the homework. Awesome.
Yeah, thanks everyone for doing the homework. And there is
cool.
a new homework for this week as well. So watch out.
Yeah, we're going to get you with that later in the episode. So let's jump into that a little bit later on. But now just want to do a quick recap. So where are we in the build so far, May? So last week, we went through and we built out a certain portion of our application, which was great. We built out essentially the asynchronous component of our architecture. So we went using the Amazon AWS Cloud Development Kit. We built out the Amazon S3 bucket for our images, so that we can upload our images from our front-end application into there. And we went and built out our recognition Lambda function in the back end there, and this is one that's going to be asynchronously processing our images as we upload them with one of our favorite services, the Amazon Recognition, which is an ML based service to do object detection, things like that within our images or video, things like that, and then storing them into our Amazon DynamoDB table that we're using to store the labels for the objects that are detected in our images and things like that. So May, what are we going to be building this week?
So yes, so this week we're gonna focus on AWS Lambda, which is like a synchronous Lambda that we're gonna build that the front end API gateway going to interact with that. So we're gonna dive deep into the AWS Lambda today, and then the Amazon DynamoDB to pull those data back to the audience. And there is another one. So if you can see at the very bottom, we have another S3 buckets. So we have thumbnail buckets, another S3 buckets that is going to be called by the recognition Lambda to store the images that for the performance purpose mainly. Like we have a big images, like because user can upload any kind of images. It could be a big size, it could be like loads of images. From the performance perspective, like it is a good approach to resize those images, create a smaller images, and then we kind of like go in an approach where we separate it out into two buckets. One is the original image, and this one that we're going to build today is the resize bucket, which is the smaller size of the original image. So that is what we're going to build today.
Absolutely. So that's really good. And yeah, like May said, it's a, for performance from our front end application, if we're pulling in, smaller image sizes and things like that, it's really going to help with the scale and performance of our application. So that's today's episode. We're going to be building that out. We're really going to focus in on our AWS Lambda and Amazon DynamoDB constructs, and we're going to dive through some Lambda best practices and things like that as we build this out together.
That is right. So should we start building? Because we've talked a lot. Yes,
we will start building. And one thing I did want to just call out as well, if you happen to see us make a mistake, and when I say we, I mean May, if you happen to see May make a mistake going through this build with a typo, type in !typo into the chat. Someone can try it out now if you want to just get a feel for it. It's going to help call us out.
Is that a typographical error?
There we go. And I just wanted to test this out because I had a lot of fun messing around with this yesterday. So when you type that in, what we're doing is we're using another AWS service called Polly. And Polly is a really awesome service that synthesizes text to speech. So what we're doing is taking that chat message and we're synthesizing it to speech and then playing it out live into the stream so that we can test that out. There is a 60-second delay on it. So if somebody types it in, it is going to wait at some time before someone else can kind of call that out. So keep an eye on us, see what's going on, if and that type of thing.
Keep an eye on the code, if there might be some typo in there.
Yeah, we've also given the mods the ability to call out and say hello. I know some of them have been really anxious and keen to talk with an Australian accent, so if you feel the urge, any mods, and you want to call something out, you can call it out using the speak command and pop that out into the chat if anyone wants to try that and give it a go. But that's for mods only. It's kind of there. But typo, call us out on it. If you see us make a mistake, let us know.
Is that a typographical error?
Yes, someone else is testing it. That's good. All right, thank you.
Good. It works.
All right. Fantastic. Cool. All right.
Awesome. So the first thing that we are going to build is the S3.
Sorry,
Yes. Yeah.
So just calling out to, I noticed one of the mods just tried that out. There is a slight timeout, so you can try that command again shortly, the walking wiki. There is a bit of a gap there I've built in just to keep it nice. Anyway, go for it, May.
Cool. So Ben, do you want to walk us through the recognition, the pillow library?
Yeah, absolutely. So one of the things is that included in the actual GitHub repository, you'll notice that we've got a folder, and if I can find it on the page here somewhere, where is it? Rec layer. Here we go. All right, rec layer is a folder there, and what this is for, it's for the pillow library for Python. So we're using pillow to allow us to make these thumbnail images. And so one of the things you'll need to do is you'll need to go ahead and grab, either go through and make that yourself, which we've got instructions for in the README file, or you can actually download a zip file that we created earlier, and you can go and extract that zip file into that folder. And so what you should end up seeing is you should have a folder structure that looks like this, where you have literally a rec folder. Inside the rec layer folder, inside there you'll have a Python folder, and inside there you'll see the Pillow assets. So if the mods could just please pop into, and I noticed that you've done that already. So go ahead and download that asset if you want to. As you're going through and building this, the repo's there. You can go and pull the latest changes from that repo, and just grab that asset, go and extract that into the directory, or it won't build for you properly. So just make sure you do go ahead and grab that asset. Okay, mate.
Awesome. Cool. So we'll go through that, what the rec layer is and how we're going to use in our Lambda function.
Yes.
So before we do that, the first thing we want to build is, if you see on the architecture diagram, we want to build the another S3 bucket, which is the resize bucket, and we're just gonna go in and build it. So first thing I'm going to do is to create a variable to get the name of the S3 Cdk resize variable. Yeah. So given the name, and what we're going to do next is to create the S3 Cdk construct. So just in here. So basically, I'm sure you are familiar where we did it in the previous show. So resize buckets, we are calling the s3.buckets, the construct, which is taking the 3 parameters, but the last one is optional. So taking this as the current stack, and also the resize bucket name, which is the ID of this construct. And we are asking for the CDK for the CloudFormation to give us the output with the bucket name. So pretty simple. So
awesome.
That's for the S3 thumbnail bucket. So we created the S3 thumbnail buckets, and the next one we want to do is what Ben's talked about, the Lambda layer.
Yeah, and before we do jump into the Lambda layer, I'm going to call you out on a typo as well, mate. No, there's nothing wrong with what you've done. But what I wanted to add is that above in the image above, what we've got is a policy.
Is that a typographical
Thank
error?
you. So we've got a policy there to go ahead and remove the bucket when we go on to do a CDK destroy, just for cleanliness. So might just get you to add that in there as well if we can, just for
what I'm going to do, I'm just going to copy that.
Yeah.
And because by default, CDK doesn't remove the buckets when you do a CDK destroy, and really good point out there. And I missed a comma.
Yeah, cool. There we go. Beautiful. Thank you. All right. Perfect.
Awesome. That's my snippet pre-prepared. So cool. So
it's all good. What could go wrong with snippets?
I would just write the thumbnail bucket when we do the CDK distro. So
yeah.
Awesome. So CDK is S3 bucket is ready. So next one is we want to use the Lambda layer on our Lambda function. Basically, a layer is one we want to include the dependency or additional libraries or some custom libraries that you want to put it into the code, but don't want to put it in the deployment package, right?
And before we jump into that layer too much, let's just have a quick chat. I just want to kind of bring up a high level. I kind of drew this quickly yesterday, so excuse the messiness of it. But the idea with this, I just wanted to explain where we're at with AWS Lambda, because I know that there are some people that are new to AWS on the stream as well. So we want to make sure that you are familiar with what's going on. So if we go back way back when, sort of in the, from a compute perspective, and think about, when we're running our applications, often with quite monolithic applications, and we try to maybe break those things up, but the networks were very slow, the CPUs were slow, messaging was based on things like XML and SOAP, and it was quite difficult. We ended up with quite heavy weight applications. But as kind of time's gone on, the networks are a lot faster, everything's a lot more efficient. We're using things like, JSON and REST, and we're able to start breaking things down into smaller pieces, which is really where the microservices concept comes in, which we're going to talk about in a second. So as these applications get smaller and smaller, it's no longer necessarily efficient to deploy those the way we used to. For example, if you've got a monolithic application and you deploy it onto an EC2 instance, that's maybe not too bad. But if you're all of a sudden breaking that monolithic application down into 4 microservices, if you've got to run 4 operating systems for that application, that's compute inefficiency, right? You're not getting the most cost-effective outcome for running your application. And so that's where we start breaking things down into things like containers, where we can actually run our workloads, leveraging kind of operating system virtualization, if you want to think of it that way. So we're not running full operating systems for every little application that we're running, so we can get much more compute efficiency that way, right, May?
Yeah, that's correct. And we slowly move into a serverless, like compute power in that sense.
Yeah. So serverless, where like what we're talking about there is that it's not that it's not running on a server somewhere. It is that you don't have to worry about managing and maintaining servers anymore. It is taken care of for you, right?
Yeah, it's good to point out that, because like if you're maintaining those physical server and hardware visualization, those operational efforts, it takes time and resources. So like in a serverless, it eliminate those operational, heavy lifting of those operational to the AWS, and you can really focus on building the applications, focus on what's really delivering the value to your customer or to your application.
Absolutely. So the next one I just wanted to kind of talk about briefly is, if I can find it here in my little stack here. Okay. All right. So this is the next one. Again, please don't laugh at my drawing. It was anyway. So the idea of this one, just wanted to briefly talk about microservices, because we probably wouldn't be doing it justice if we didn't, mention microservices when we're talking about AWS Lambda. So as we're breaking these applications down into smaller services, these services are, very purposeful. They're, kind of inclusive, and they're defined, or at least we're leveraging a well-defined API to communicate with these things. And so this is an important concept, because there are a lot of different tenets when we talk about microservices that kind of come into play when we're designing and building microservices. Things like bounded context. I don't know if anyone's heard of that before, but it's part of domain-driven design, and it's one of the kind of, key components in there where we're breaking our application down into different bounded contexts depending on what the business function is. And so you can see in this example, we've got our traveler, which I know we're not all doing a lot of at the moment, but we've got our traveler there, and depending on the bounded context we're sitting in, that traveler could either be called a passenger or a guest, right? If they're on an aircraft, often that's a passenger. If they're staying in a hotel, that's often a guest, right? The terminology is different between these two bounded contexts, and we call that the ubiquitous language which we're using, and this really helps us build our classes and things like that to be make the most sense, right? And so often what you see is microservices living within a bounded context, because then we can really kind of make sure that they are purposeful. We don't end up with a big kind of ball and mud application and things like that. So it really helps. But what I wanted to point out with this mostly is that within our microservices, it's very much polyglot, right? Because when we're deploying via either containers or serverless functions using things like AWS Lambda, we can choose the application or the development language that we want. So that would obviously be Python, right, John? That would be the way we would roll with that, right? Okay, may not agree there, but it's polyglot, right? And so it really helps us to have freedom of choice
that you're familiar with. And also the storage service, it doesn't have to be a one particular type of storage. It could be a NoSQL key value.
Node's the best.
Thanks, John. Nice Aussie accent, by the way.
Thank you. So it could be a SQL database, or it could be key value, lots of database like Amazon DynamoDB. So it depends on the use case, depends on how we want to build these applications, and obviously it's built for its own purpose. And if the use case relies and you have options of choosing the right data store that you think it is suitable.
Yeah, the most relevant data store for that service, right? And that's one of the tenets of being a microservice, is that they don't share, right? If one microservice wants to, get information from another microservice, that's an API call, right? Like the idea is that each microservice owns its own storage, and that's kind of one of the key tenets of being a microservice.
Awesome.
So anyway, so that's a quick kind of run through. If you're interested in diving into that any more detail, we do actually have a whole deep dive on this in our Advanced Developing on AWS course. Just to give it a plug there, we dive into decomposing monolithic applications into microservices, and we dive into dealing with things like distributed complexity and managing distributed systems at scale. So if you're interested in that, great kind of call out to go and deep dive on that. But what I do want to do is now just quickly bring up Lambda, because Lambda is my favorite service and I could talk about it all day, but we just want to call out that is a regional service. We can use it with synchronous or asynchronous processing, and it's going to execute your code for you without having to worry about the compute. Recently at reInvent last year, which is a really large conference that we have each year for AWS, we increased the memory space, so you can have between 128 megabytes of memory up to 10 gigabytes of memory for your function.
Yeah, that's a very exciting release, and I was really looking forward to that. Yeah,
absolutely. It's super cool. And we've got 15 minutes runtime. So the idea is that we want your function to run within 15 minutes. That's the timeout for the function, the maximum you can go up to. It's extremely efficient because when you're not using this, you're not paying for it, right? You get billed in your 1 millisecond lots.
Exactly.
So you're really paying for execution time of your functions, which makes it really great. And as we've called out, it's polyglot and it's great for microservices and building microservices within AWS. So anyway, May, I think we've yabbered for a bit. Let's get back to the code, right?
We do. So I can see in the chat from Kazanari, my audio is a little quiet compared to Ben, so I'll try to speak up a little just to make sure get that. Matt, Bevan, Sydney, May's awesome. Thank you. I need that.
I've cranked your audio a little bit, May. Let's see how that goes, shall we?
Okay. Awesome.
Okay. If not, you can just get Olivia to talk on your behalf or something.
Yeah, we should try that next time.
Yeah, that's right.
So what we're going to build now, and so Ben's talk about Lambda, so we should build Lambda now.
I'll talk for May.
Always.
Okay, who was that? Walking Wiki. Thanks. Yes, you can talk for May. That's good because you sound great with a female Aussie accent. I'm just saying, it sounds awesome. Okay, all right. Okay.
Cool. So the first one we're gonna do is we just creating the layer for the Lambda. So we're gonna use the pillar library that Ben mentioned. We're gonna include that into the recognition function. Why? Because recognition function is the one that's going to process this image, and when we process that image, we want to do the image or process the image in a way that is more efficient and decompress and do the image processing with this pillar library, but we do not want to include in the development or deployment package. So we're going to include as a layer. It's very straightforward when you do the Lambda layer with the CDK. With Lambda layer version. Thanks for drawing. And we have got, as usual, the code access is coming from the recognition layer. So I copy the recognition layer folder into my project, so the Lambda can pick it up from there. And we've got runtimes, the license and descriptions for these layer. So we have got the layer, and then the next one we want to do is to add layer to the recognition function. So just down here, what I'm going to do, I'm going to add recognition layer just in the function. So now we have introduced layers, and it's just referring back to the one we just created.
Yeah.
Awesome. So that is for the layer.
And just to point out here, this, if I don't know if a mod wants to put in a link to 12-factor, but if you're looking at 12-factor, 12-factor app number 3 is to separate your config from your code, right? So that you can have multiple deploys from the same code. We're putting these in the environment variables so we can access those. Yeah, it's good practice. Yeah.
Exactly. So thanks for pointing it out. So next step, what we want to do is, if you remember, we created the S3 buckets here for the resize buckets, and we want to put it into environment variables in the recognition Lambda, because we're going to use that in the future to, after we resize, we're going to store it into this resize bucket. So next one, since we are already on the Lambda function, I want to put the environment variable, so we can reference that in the recognition function. So basically a thumbnail bucket, environment variable, and just the name of the bucket. So we've got that bucket, but we need to add the permission to allow these Lambda function to write into the, or to put the object into the resize bucket. So what I want to do next is to add a permission. So basically very simple. The bucket, the resize bucket, is granting the put permission to the Lambda function that we just written. So that is pretty much for the Lambda. Next one is to go over to the Python to look up these recognition Lambda function. But before we do that, we are halfway through the show. So
It's now time for our BuzzerPy API challenge.
Said it on your behalf there, mate. Okay. All right.
Cool.
So should we explain how this thing works? So the BuzzerPy API challenge, we're going to try this one more time. We had kind of some interesting things going on last time. So I have taken another look at my code, which was probably why it was failing. And we're going to go and have a rerun of this. It's a different question, but to set the scene, all it is, we're going to pop up a question on the screen, and your job is to answer the question, type the question or the answer to that question exactly as is into the chat. And the first person to answer it correctly will be the winner. And that's pretty straightforward, right? So should we give it a go?
Yeah.
Let's see if it works this time. All right. Perfect. Let's go. All right. Question is, AWS Lambda left preview and was made generally available in which year? And this is a tough question. We haven't covered this, and it's going to be interesting to see who gets it first.
Congratulations,
we have a winner.
Zero Jedrick Zero. You are the winner.
Awesome. All right. Congratulations. You are the winner. Now, congratulations. That's awesome. Well done. It was, in fact, released in 2015. So as a GA, it became preview. If somebody wants to type !buzz off into the chat, please, for me, just to turn this buzzer off. !buzz off. Thank you. All right. All right. Perfect. That's awesome. Congratulations. You're awesome. We love that you answered that so quickly. Fantastic. All righty. So, May, let's go back over to your screen share.
Let's back to the code bit. We had some fun.
Yes, that was good. That was cool.
That was good.
And my code worked, so that makes me super excited. All right.
And now this time my code has to work this time. Okay. So we have a recognition Lambda function. So now we are in the recognition Lambda function. What we want to do is we want to include the pillar libraries into our function, so we can do some processing. So first, what I want to do, this is not CDK. Python's just include some package and something that we need to use it in the code. So we just introduce the image, imported image from the pillar library, just picking up the environment variable from the CDK that we declare. So that will just getting the environment variable name. So next one, what we want to do, we want to create Python function.
Yep. And just to call out while May's doing that, so as you saw earlier, one of the best practices that we are instantiating our service clients in the global scope of our application as a best practice to maintain performance. And so we're going to go through. We're creating the generate thumb function, May.
Yeah, so generate thumb is basically just to, the image is to generate a smaller image, to resize that and put it into a resize S3 bucket. Very simple. The job it does is just to, getting the value picking up the images from the images from the original buckets, download the file, do the resize thing, get the resized image here, and upload it into a new upload file is basically uploaded into a new thumbnail buckets.
Yeah.
So very simple simple function.
Yeah, so we're just using the S3 service client that we declared globally, and then the upload file method. Pretty straightforward. And yeah,
cool. So
hopefully
we've
works.
got the generate thumbnail function, so we have to call it from the handler so that we can use it.
Mm-hmm.
So Python, I hope I have snippet. So yeah.
Now, those that are new to AWS Lambda as well, if you're wondering, so events is the object that gets passed to AWS Lambda when we invoke it. So that's how we pass our parameters and things to it. Context, if you use it, we're not really using it in this case, contains a whole lot of useful information, like how long your Lambda function is been running, and things like the request ID. If you're getting requests coming through, for example, Amazon API Gateway, which we're going to talk about later, maybe you want to trace the transaction across your backend microservices to see what's going on and understand what's happening with the transaction. All of that goodness can be found in the context object, which is super handy.
It is. Cool. So since we're on the Python Lambda, let's move on to the next one. If you remember from the architecture diagram, we have another Lambda function. So that Lambda function is interacting with the front-end API gateway. So when the API gateway sends the request to the Lambda function, Lambda is going to do some processing.
Yes.
So there are two jobs that another Lambda is going to do, which is we call it Service Lambda.
Yeah, so, Service Lambda. It's very
Service Lambda, yeah.
Aptly named. We put a lot of thought into that one. So, no points for that. But
discussion around that.
Yeah, absolutely. Okay.
So Service Lambda does two jobs. One is to getting the labels, the images that already stored on the S3 buckets. We want to pull the images back to the user when the user requests that image. The second job is to delete the image. So basically, if the user want to delete this image, we should be able to delete that in this Lambda function. So what I did was I have empty folder called, it's not empty folder, just a folder called Service Lambda, and I have empty file called index.py. So basically a Python empty file. What I'm going to do first thing is to, as always, import some packages into this before we start using that. So maybe a bit too small.
Yeah, that's better. Thanks,
that's
mate.
Better. So import some package into the Python, S3 and DynamoDB. That's what we're going to use. The first thing we want to do in the Lambda is to get the handler ready. So handler is the first point of contact for the Lambda function. So
yeah, so just to let you know, so the Lambda function, when you invoke it for the first time, is going to become hot. It's going to execute, and it's going to stay running for a period of time, so that when you invoke it again, it's going to be ready to rock and roll and execute your code. So it's going to keep just calling that handler function whenever the API, whenever you call that AWS Lambda function. So one thing to note is that we have another feature called provision concurrency. So if you want to pre-warm a whole lot of Lambdas ready to go to really just bring that latency down even more. So if you've got, for example, a gaming application or something like that, and you just want to bring that latency down, you can pre-provision AWS Lambda resources as well now.
Yeah, and that's really helpful to pre-warm the Lambda, so it can quickly get up and start, processing the function much quicker.
Yeah, so, and it's quick to come up, right? But it does go to sleep after a while, which is kind of why it's an event-driven, I guess, resource, and it's super performant like that, because you just you're only getting paid for what you use. Anyway.
When you want to fine-tune that, those features are pretty helpful, and you will see the difference between pre-warming the Lambda function and not pre-warming it. So pretty cool. So all right, let's go back to the Lambda, the handler.
Yeah.
We drifted a little. So in the handler, the API gateway, the API gateway is the one who is going to trigger this one. So what it's going to send is the event with two events, not two events, event with two objects. With one is the action and then the key. Then we just create a new object that we're going to use later on. And if we look at this one, it's very simple in the sense that like if the action is get labels. So like I said, there's only two actions that API Gateway is going to trigger. So action is get labels. We're going to create get label function in a minute. It's erroring out at the moment. So get label, we're going to call get label functions, pull the images and return it back to the user. If the image is not found, we return no result. Next one from the API is the delete request. So if the action is delete image, call the delete image and return back what has been deleted. Otherwise, we raise the exception of images not detected or recognized in this sense. So that's pretty much the handler stats. So it's like a parent function, and it's just calling to the two other methods that's going to use. So next one.
And just to call out as well, and that is a best practice, is to generally separate the business logic from your handler function. So, one of the things you want to get into if you're starting with AWS Lambda, you don't want to define all your business logic in that handle function. That becomes just a wrapper that calls the other functions. It's more unit testable. Whilst we're not taking like a test-driven design approach here, we're kind of just going straight into the guts of it. It is something that you need to consider and think about as you're going through.
We haven't started from the test.
Exactly. So all good.
Maybe we'll do it next show.
Yeah.
Cool. So next one, this snippet is just the get labels function. So what it's going to do is, because the get labels is passing down the image, the objects that we constructed here, passing down the image key, which gave the key, the image key that's API Gateway gave it to us, and retrieve the environment variable that we declare in the CDK, and then we have a DynamoDB table just to pull those data. So we initialize the DynamoDB here, and then table.getItem is to query the item from the DynamoDB with the key of the one that it passing down from the handler. And response, and we've got objects with the item, and the response is returned back to the function. And if there is nothing, if there is some issue, then we raise the error and return with no labels or no error if there is no image exist in the DynamoDB. So pretty simple in that sense. Get labels. Another one that we have to create is the delete image. So
yeah, so this this function, so the get labels function, that's really going to be our get method within API Gateway. So next episode we're going to integrate this Amazon API Gateway with our Lambda. So it's going to integrate with a get method, and then we've got a delete method through the API, which we're going to integrate with our delete image, or the same Lambda function, but it's going to be calling the delete image. Yeah.
Awesome. So so delete image. Very simple. We got the key, we got the environment variable, initialize the DynamoDB, and call the DynamoDB function table.deleteItem to delete this key. And if there's an error, we log the error.
Yeah, and I guess it's probably not a bad point to just have a quick talk about Amazon DynamoDB as well. So let's just have a quick chat, because we're talking about it, and it probably makes sense to talk about it some more. So Amazon DynamoDB is awesome. It is a NoSQL database, fully managed. It's a regional service. It is a key value document store, and it's got really amazing scale. So the idea and the way that this has been engineered is that it's designed to give you single digit millisecond latency at any scale. So it becomes an extremely performant way of storing data within your application. It does have multi-region as well as multi-active tables. So we can have multiple tables in different AWS regions and have them all asynchronously replicating to each other, so that we can have them all hot, so that we can have multi-region applications, which is amazing. We've also got streams, so you can set up DynamoDB streams so that you can then have, for example, an AWS Lambda function triggering based on making changes to your actual table. So the idea is that if you want to respond really quickly to an event, like somebody just signs up for your application or registers and you want to send them a welcome email or something like that, you can do that straight away. As soon as that change is made to your table, it's event driven, right? And it allows us to really respond to those events really, really quickly. The other thing we have for DAX, if you know single digit millisecond latency, you want more, you want faster. We also have what we call DAX, the Dynamodb Accelerator, and this is a cache which is completely API drop-in compatible with DynamoDB, so you can make your requests through DAX, and we're talking microsecond based latency for that one. So it's a great solution. And May, it shows up in so many architectures, but really common use cases are things like user profile, shopping cart. If you're, for example, going and adding items to your shopping cart, things like that. That's you want to capture that data really, really quickly, and be able to,
after you capture that, you will process that data straight away, and you can interact with the user while they're still on doing the shopping cart, and you can interact with them straight away, processing those data. So having those milliseconds latency and be able to query that really quickly, it's very useful in many use cases, like Ben said, like shopping carts. There are many other features and use cases like gaming, for example. And just calling out the chat, a couple of things there too, May. So input space. So thanks for answering that question for us as well. So so there's no locking mechanism with DynamoDB because it is a key value document store. It doesn't have a structured schema in the same way as a relational database does. But we can do things like conditional writes. There's ways to get really strong consistency. So we can request strong consistency when we query the table. And things like that. And it also has a transaction API now as well, so that we can have transactions across multiple tables. So it's a really feature-rich application. So it's definitely worth diving into if you want to kind of build applications that just scale really, really well. All right, I'm just going to flip back to your IDE there, May. Sorry, please. Go on. I think I caught you in awesome. No, those are really good questions. There are questions in the chat. If we can't answer it on the fly, we will look at it. We will review this after the show, and we'll come back to that definitely on the next episode 3.
Yes.
So we've got two functions here in the service Lambda in the Python code. So what we need to do is we have to create the CDK for this Lambda. So going back to our CDK, we are slowly building up. So the code is getting the lines of codes are getting longer, which is good, and we're building week by week.
Yeah, and we're just still continuing to define this in the AWS Cloud Development Kit. If you missed last week's episode, please go and have a look through. We talked about the AWS CDK. You can go and rewatch that. If somebody wants to pop the episode's link in, if it hasn't been already, into the chat, definitely go and watch through that. But we're just going to continue building in the AWS CDK so that we can our whole infrastructure is defined as code, which is again just another best practice.
Exactly. So cool. So we have service Lambda. We create the service function using the construct of the Lambda function. This idea of this construct, the code is coming from the service Lambda that we just created in the Python. So that is just referring to the code runtime with Python 3.7 and pointing it to the handler, index.handler that we talked about.
And this is really the file and the file name and the function name that we're trying to call. So it's going to look inside, for example, in this case, like index.py for the handler function, right? So that's kind of how we're defining that.
Exactly. Cool. So, and then we have 3 environment variable. We use that in the service Lambda to refer back to the tables and buckets. So that is pretty much we have for the, I forgot to mention about the permission,
Yeah.
the most important one.
We have to define the permissions. Yes, and always follow least privilege when you're doing this. And so the idea is we definitely want to be, following this pattern. But you'll see in this case, we're granting right permissions to our image bucket so that our service function can work, right? So it can do what it needs to do. So if we're, for example, deleting an image, it has the ability to go and delete that image from the bucket.
Yeah. That's right. So because when the user requests delete image API, we want to delete DynamoDB data feed, right? We want to delete the data in the S3 buckets. And we have two S3 buckets. So we want to delete both of the S3 buckets, and we give access to the service Lambda to be able to delete those two buckets in the file.
Yeah, and so good question as well in the chat there. So can those rights be granted from the GUI instead of in the code? Absolutely. You can go into Identity and Access Management in the AWS Management Console and grant all of these permissions. The only reason why we're doing it in here is because we want it defined as code so that we can repeat it. And so the idea is we can just build this stack and then tear it down and then build it again and tear it down. And it gives us a lot of flexibility later on when we setting up our continuous integration, continuous delivery, continuous deployment pipeline so that we could just tear up and down stacks. Yeah, infrastructure as code, exactly.
Everything we do here, we can definitely do it in the console, but the main benefits is like Ben said, it's more repeatable. We have less human errors, like granting those permissions, because there are pieces of components, because it's microservices. So it's hard to manage in that sense, and having everything in one place with the CDK and repeatable manner is pretty helpful. Cool. So this is pretty much, we have built a Lambda function, we have built S3 buckets, we've written some Python. Well, it was a code snippet.
Yeah, but, absolutely.
So we have got that. The next one we should do deployment and test it out.
Yeah, let's do that. Let's see if May has made any mistakes. This is always my favorite part, because you never know what's going to happen. No, I have confidence in your snippets, May. I'm sure that there was no
you never know. So
main challenges in there.
Is that a typographical error?
Thank you.
Is that error? No.
I don't.
So I'm going to do CDK synth to synthesize the CloudFormation and to get the full CloudFormation template.
Yeah, so this will give us the full canonical CloudFormation template. There we go.
So also we have, that seems all right. I'm not going to go through all of it.
Yeah, let's not go through line by line because we have 10 minutes left in the show. So, but
okay, let's deploy it. And so we already deployed the components from the previous episode. So what it's going to say is just some of the changes, like DynamoDB, some permission changes, some changes to the recognition image buckets. What else do we have? Service Lambda permission. So that seems pretty okay. So I'm just going to deploy this, see if that works. So basically what it's doing is creating CloudFormation change-it.
Yeah. And this part here at the start as well, just as it's going through, it's creating the assets from those directories, right? So from our AWS Lambda directories that we have our code, and also the layer that we've created as well, it's packaging those up into zip files and pushing those up to the staging bucket in your account so that we can deploy them. So the AWS CDK CLI does that for you, which is kind of cool. Yeah. Go, May.
But it's still deploying.
It is still deploying. I
have to wait a few minutes. We have to wait a few minutes. But it's creating, as you can see, creating Lambda. Because you have to watch, this is going live, so you have to wait and watch it.
Yeah, that's right. Yeah. So good question. Is there a way to import existing resources into the CDK? I don't if you've got existing resources into your account. I don't know of any easy way. I don't know if any of the mods do that. Just kind of transcodes it back into. I think you've pretty much got to define the constructs. Yeah, there's not. If anyone knows, we can find out, but I don't think there is off the top of my head.
Yeah, I haven't tried to migrate, the existing resources. I've tried a little with Sam, just to like migrate it into, but it's much easier to put those resources into the CDK.
And if anyone wants to know what SAM is, serverless application model, if you haven't tested it, it's actually this is the icon. Cutest icon that we have at AWS, I think. That's Sam, and Sam is cool. He's the idea is that Sam is a transform on top of CloudFormation, so that we can define our infrastructure in a simpler way. It's kind of like the CDK, but it's not using the familiar programming languages. They're actually JSON YAML, but there's also a CLI that we can use to test our AWS Lambda functions locally, so that we can test them. It basically spins up a Docker container, so you do need to have Docker installed if you're going to use it, and it'll allow you to test your Lambda functions locally before you push them up. And you can use that with the CDK as well. So just throwing it out there.
Awesome, that's
cool.
great. So the package has been deployed. Let's do some testing, fingers crossed. So what I'm going to do, I'm going to upload the image. So I've got the same image from last week. Upload the image into my S3 buckets.
Creature of habit, I tell you. Okay, all right. Could have mixed it up and thrown something, Anyway, go for it. Upload it. Oh, we are good.
Cool. So I uploaded these images into my S3 buckets.
Yeah.
And the next one is we want to see if there is any data. So once we upload the image, the Lambda should process this image, resize those image, call the recognitions, and store the result back into the DynamoDB. So let's see if we have anything in the DynamoDB. And after that, we would do the Lambda testing.
Perfect.
Cool. So I've got DynamoDB. I just want to see if DynamoDB has been, yes. So it has the animals, test.jpg, kangaroo image I uploaded. So it's stored into the DynamoDB. But we want to see service Lambda. So because that's the new Lambda function that we created. So we want to test the service Lambda to see if that actually works. So, but to test the service Lambda, to change things up a little, I want to jump onto the console and test it from the console.
Perfect. All right. So let's bring up the console then. And so one of the things, again, just to point back, will you bring up the console, mate?
Hold on. Just 1 second. I'm just trying to log into my console.
Okay. No problems. So we can obviously do this testing from within the CLI as well. We can test Lambda functions directly from in there. We just want to mix it up a little bit and just show you how to test within the console as well, within the AWS management console, because it just gives you a good feel for it, and it that way we can kind of show you the interface as well, if you want to see that one.
Awesome.
Okay.
So I'm gonna switch to my screen sharing to my console.
Okay. Got it.
Let me do that.
Cool.
So,
all right.
Awesome.
CLI, I haven't heard of that since Amiga days. Oh, I remember those Amigas. They were cool. Was it the Amiga 500? That was an old school cool machine, that thing.
Yeah, right. You can talk about it all day, can't you?
Yeah, I remember those. Those are good old days. All right.
We're in the console, the Lambda function console. So I just go onto a Lambda function console and we would do some testing. We have 2 Lambda functions, and first thing we want to do, we want to test the service Lambda, because the service Lambda is going to do, if you remember, 2 jobs: get labels and get image and delete label. So first, what I want to do is to test the get labels. So if you see the image that retrieved from the DynamoDB, but this one is retrieved from the Lambda, and see how the Lambda responds.
And what are we passing through for this, May? So we've got the
action.
Action, and get labels.
If you remember that, we did it in the Python. And key is the test.jpg, and see if that do the... Perfect.
Oh, yeah.
Labels.
All right, so this is the console view, and so you can see here that we executing the AWS Lambda function. We've got our return. So what we expected, same as what we got through the AWS command line interface as well. But we can test it from within the console.
We can test it from the console, and this is what we get. Next one, I want to delete that
Check your
image,
banner
so-
placement smile.
Nice
Okay.
one.
All right, let's.
All right, I'm just gonna test
Smile.
the delete
Thank you.
image.
All right. Is that better?
Is that better?
Thanks for calling that out. I don't think Olivia knows what the emojis are. Oh, maybe she does. She called it a smile, so that's kind of good. Anyway, go for it.
So we're gonna delete the image. So I just put in the delete image actions and the same key name, and if we test it, it should be deleted from that.
Perfect.
So
So we
delete
got that
request.
response.
So the Lambda function works, and next week in the next episode, we're gonna integrate with API Gateway, and then from there we can fully test it the function of from like the request to the Lambda and then the Dynamo.
Got it. Okay.
Awesome. So that is
Perfect.
pretty much. So we build the code, we write some Python, and we deploy it and test it.
Yeah, just to call out, apologies about that blocker there. It is just hiding some details there, so that's why it's there. It's kind of I hope it wasn't in the way too much. That's all good. Okay. Awesome. All right, so that takes us basically to the end of the show. Thank you so much for joining us again. We hope that you, it's helped sort of enlighten you a little bit into AWS Lambda and Amazon DynamoDB. Amazing services, definitely worth spending, some time on. And we're going to continue working with them throughout this build. But absolutely, thank you so much for joining us. Hope everyone has an amazing week and weekend coming ahead. And hope to catch you all here next week as well, where we're going to go through into Amazon API Gateway and continue our build. Before we go, homework, May.
Yep, homework for next week.
Yes. So what are we asking for this week?
What do you want to ask? We're going to post it on the LinkedIn as well. So if you're following on the LinkedIn, you will see that on the LinkedIn post.
Just head in hand homework. Okay, so go and check the post. We're going to post that for you, and go and do it. We'll call you out in the show. It'll be cool. Right. Thanks everybody. Thanks for joining us. Awesome to have you all here, and we'll catch you all next time around.
Thank you.
Have a great day.
Bye.
All right. See ya.